In the previous episodes, I demonstrated how the tool heads and switch wires are arranged around the printer. This episode will focus more on the design of the motion mechanisms for the floating bar. Hi, welcome to Slow Engineering. I'm David. In the previous episodes, by testing the bell reduction unit, I confirmed that the steppers has the same reduction ratio as the ZSX on the Voron 2.4 printer. The reduction mainly provides resolutions rather than torque. I plan to use a similar mechanisms on the printer's ZSX to drive the floating bar motion system. The output pulleys on the reduction shaft is a 22 GT2 pulley that drives a 6mm width bell. This will be combined with the redirections pulleys on the top, and the bell will be connected to the other side of the floating bar. I started with the stepper reduction. After conducting experiments with the reduction unit, I redesigned the relationship between the gearbox and the profile. In the initial design, I tried to attach the entire reduction to the panel, which would require a solid door panels to support the gearbox. However, having a large panels under stress isn't a good idea once the bell is tensioned. So I make some changes to install the gearbox to the profile directly and cut a space for fitting the panel, using 3 screws to fix the parts together. The last corners of the gearbox doesn't pass through the panel, and a threaded insert is needed to fix the reductions outside the printer. Making a hole in the panels and fixing it on the other side also doesn't make sense. The holes on the panels would be the output shafts with pulleys. This solution avoids putting too much load on the panel. For corners, I attach 2 corners at the top to secure the panel, which is similar to the corners parts I fixed at the bottom profile. Even though all 4 corners are fixed, there is still a gap between the panels and the profile. This gap is intentional to accommodate D-shaped rubber strips. These rubber strips will be placed all around the inner side of the profile and will ensure an airtight seal once the panel is installed and pressure is applied. Additionally, I designed the 4 corners parts inside the panels to protrude and support the panel, ensuring it stays in place and does not interfere with nearby pulleys or the moving floating bar. In addition, let's discuss panel supports in these corners. The upper 2 parts redirect the timing bell like the ZSX and guide the bells to the floating bar. I used the original design as template to create them. The holder has a pulley with a 20mm screw. The housing parts has holes for fastening on the top profile and a hole for a threaded insert. Once the pulley holder is ready, lightly fasten the holder with the screws to the housing. Keep it loose until the bell is installed at the floating bar, then tighten the screws to tension the belt. The housing and profile slots will keep the holder aligned. The protruding planes on the housing provides additional stability to minimize deformations with the holder. The bottom corners are for the sensor cable mentioned earlier. Once the coiled cable reaches the bottom, it should be fixed and guide outside the door using the profile rail. Initially, the plan was to find a suitable coiled cable dimensions to fit the space. However, I discovered that custom making coiled cable for this application is more practical. The foam part can be installed in the lower sections of the profile before the cable is secured. Adjust the positions of the cable and then fix it in place using the back part and 2 screws. The protruding shapes on the side helps to align the parts with the side profile. These cable fixing parts ensure that the coiled cable extends in the assigned space and prevent it from interfering with the nearby timing bell. I adjusted the bell fixings on the floating bar to ensure the bell aligns correctly with the pulley and remains parallel when tensioned. Next, I will test whether the sensor cables can be coiled. If it can't, I'll determine which installation suits this application most. As always, moving forward,